Good morning, class 11th. Today we are going to do problem sums on solution of triangles. We have already done few sums. I'm going to do few more so that you get enough practice sums solved with you. There are plenty of sums which are there which you will have to solve yourself. Until unless you don't do it yourself, there is no point. I can do them. I will do them for you to show you that how can you solve the different kind of problems. Like if you look at the first sum, sine b minus c upon sine b plus c is equal to b square minus c square upon a square. Now we know that in solution of triangles I have sine law, which is sine a upon a is equal to sine b upon b is equal to sine c upon c is equal to k. Or if I reverse, it becomes a upon sine a is equal to b upon sine b is equal to c upon sine b is equal to k. K is 1 upon k will be another constant. But I'm not getting b square minus c square upon a square. These square terms we get for cosine laws. Cosine law is like cos a is equal to b square plus c square minus a square upon 2bc, or cos b is c square plus a square minus b square upon 2ab. Things like that. So let us see how do we solve it. Like I have sine b minus c upon sine b plus c. I have to prove it equal to b square minus c square upon a square. I'm starting with left hand side. I'm starting from left hand side. What am I going to do is I'll apply sine b minus c means sine a minus b. The formula for sine a minus b is sine a cos b minus cos a sine b. So here it will be sine b cos c minus cos b sine c upon sine b cos c plus cos b sine c. Now I can convert sine b sine c in terms of, as you know, that I can write it as bk. Why? Sine b upon b is equal to sine c upon c is equal to k. So sine b I can write in terms of bk, and similarly sine c I can write as ck. So I can write it to be bk, and cos c I'll write the formula in terms of a square plus b square minus c square upon 2ab, minus again sine c is ck, and this cos b I'll write as a square. Cos c was a square plus b square, cos b will be a square plus c square minus b square upon 2ac. Denominator has sine b, which will again become bk, and cos c will be this, a square plus b square minus c square upon 2ab, and this will be, instead of just, it will be plus and it will be ck, and the same thing will be there, a square plus c square minus b square upon 2ac. Now what we can do is, we can take out what is common. bk, b will cancel with b here, c will cancel with c here, similarly b will cancel here, b, and c will cancel with c. So what will be left here? K upon 2a common, k upon 2a common. In numerator, k upon 2a is common, k upon 2a is common in the numerator. And what will be left? A square plus b square minus c square, and this is minus, so signs will change here. It will become minus a square minus c square plus b square. It will be divided by, again I'll have k upon 2a as common. So k upon 2a will be again common, and it will be a square plus b square plus c square minus c square, and here instead of minus it is plus, so there will be no change of sign. A square plus c square minus b square. Now these k upon 2a will cancel with each other, from numerator to denominator because they were multiples. Now let us see what can I cancel here. A square is minus a square, b square is plus here, plus b square minus c square minus c square. So they will not cancel. Let us see in the denominator. B square plus b square minus c square minus c square plus. So in the denominator, in the numerator, I'll be left with 2b square minus c square. Because 2b square minus 2c square, I'll take 2 common. And in the denominator, I'll have 2a square. So 2 will cancel. I'll get b square minus c square upon a square, which I have to prove. On the right side, I have b square minus c square upon a square. So once again, sin b minus c was written as sin b cos c minus cos b sin c upon sin b cos c plus cos b sin c. Sin b and sin c were replaced by kb and ck, bk and ck using the sine law. Cos c and sin c were replaced by a square plus b square minus c square upon 2ab, a square plus c square minus b square upon 2ac. We applied sine and cosine law both, converted them in terms of a square. Whenever you see the square, I have to get a square in the answer. So square side of the squares, the square of the sides have to come. So we applied cosine law. Then it is plain algebra. We took out common, we cancelled whatever we had to cancel, we added and subtracted, and whatever we could cancel, we cancelled out, and finally we got the answer as what we wanted. Now let us see question number 2. In question number 2, I have a sine b minus c, a sine b minus c plus b sine c minus a, b sine c minus a plus c sine a minus b. I have to prove it equal to 0. We have to prove this to be equal to 0. Now for proving it to be equal to 0, now a is there. A is there. You know a upon sine a is equal to b upon sine b is equal to c upon sine c is equal to k. If I reverse that, that will also be correct. Depending upon where do I, in the first question I applied the reverse. I had to replace sine b and sine c. So I said sine b was equal to ak or sine c was equal to ck. But I have to here have a. So a can be k sine a, b can be k sine p, and c can be c will be k sine c. So I can put these values k sine a, k sine b and k sine c in this. Let us put these values. Like it will be k sine a into sine b minus c plus k sine b sine c minus a plus k sine c into sine a minus b. K is common, I can take out the k out. K is a constant, it cannot be equal to 0. Now sine a. Sine a can be written as sine 180 minus b plus c multiplied by sine b minus c. Sine b can be written as sine 180 minus a plus c or c plus a and sine c minus a plus sine c can be written as sine 180 minus a plus b minus a plus b, and it is sine a minus b. It's complete bracket. Now k is outside. Sine 180 minus theta is sine theta, so it will become sine B plus C and sine B minus C. Similarly, it will become sine C plus A. You write A plus C or C plus A, addition is the same, sine C minus A. Similarly, sine A plus B, sine A minus B. We know it very well that sine A plus B into sine A minus B is sine square A minus sine square B. So sine B plus C into sine B minus C will be sine square B minus sine square C. These are the laws which we did in the beginning. If you go through my earlier videos, or if you are making notes in your exercise notebooks, then you will find them. Sine square C minus sine square A plus sine square A minus sine square B. It is very simple. Sine A plus B is sine A cos B plus cos A sine B. Sine A minus B is sine A cos B minus cos A sine B. You multiply them and you will get finally the product in terms of sine square A minus sine square B. Here you will realize sine square B is plus, sine square B is minus. Sine square C is minus, sine square C is plus. Sine square A, sine square A. So it will be K into 0, that will be 0. So we are able to get the value of the whole expression on the left side equal to 0. What we did was A sine B minus C. A was converted in terms of sine, K sine A. B was written as K sine B. C was written as K sine C. Then sine A, because ABC this is happening in triangles. This is solution of triangles. So A plus B plus C is 180. So A will be equal to 180 minus B plus C. And here it is B minus C. 180 minus B plus C is sine B plus C, sine B minus C. And similarly, it will become sine square B minus sine square C. Exactly in the same fashion, both the other terms will you get sine square C minus sine square A plus sine square A minus sine square B. You get 6 terms. Out of 6 terms, 3 will be minus, 3 will be plus, and they will be similar. They will cancel with each other and you will get equal to 0. So from left hand side, we were able to obtain right hand side equal to 0. Now let us see the third sum. This is second sum. And let us see the third sum. He says A is 2, B is 3, C is 4. Prove that cos A is 7 upon 8. We know what is the cosine formula. Cos A is B square plus C square minus A square upon 2BC. B square plus C square minus A square upon 2BC. We have got the value of A, we have got the value of B, we have got the value of C. Let us substitute all the values in place of A, B and C. A is 2, B is what? 3. 3 3s are 9. Plus C is 4, 16. A is 2, so 4. Upon 2B into C, 3 into 4. What will you get? 9 as 16 plus 9, 25. 25 minus 20, 21 it will be. And 2 into 3 into 4. 3 7 by 21. 7 upon 8. So cos A is equal to 7 upon 8. That is what we had to prove. He has given you the value of A, B and C and he wanted you to prove cos A is equal to 7 upon 8. So we have applied the cosine law. We have applied the cosine law, substituted all the values. We got the value of cos A, that is 7 upon 8. Now let us see the next question, the fourth one. I have, if the sides of a triangle are 7, 4 root 3 and 13. Suppose A is 7, B is 4 root 3 and C is root 13. 7 is the biggest side. This is 4 root 3. So 4 into 1.732. root 13, what is the value of root 13? Nearest root 13, if you take out, you will do 3 3s are 9, 4 4s are 16, can't go. It will come 3 point something. It will come 3 point something. So C is the smallest side. C is the smallest side, A is the largest side. Now he says, if the sides of triangle are 7, 4, root 3, root 13, prove that the smallest angle is 30 degree. Now C is here. We have to calculate, let us calculate all three angles and see what happens. Though the smallest angle will be just opposite to C, just opposite to C, because this is the smallest side. So actually I need to calculate cos C only, because smallest angle is opposite to smallest side. That is the basic law of geometry, that the bigger side, the bigger the angle opposite to it, the smaller the side, the smaller the angle opposite to it. Bigger side will always have bigger angle opposite to it. The smaller side will always have the smaller angle opposite to it. So cos C will be B square plus A square minus C square upon 2AB. Now B is 4 root 3 whole square plus A square is 7 square minus C is root 13 whole square upon 2 into A, that is 7 into B is 4 root 3. It will be 16, 3s are 48. 4 4s are 16, root 3 into root 3 will be 3. So 14, 16, 3s are 48. Plus 7 7s are 49. Minus 13 upon 2 into 7 into 4 root 13. 4 root 3. 48 plus 49. 97 minus 13 upon 2 into 7 into 4 root 3. It will be 84 upon 2 into 7 into 4 root 3. 12 times it will cancel. 2 6 are 12, it will come. 2 3s are 6, 2 2s are 4. So 3 upon 2, sorry, it is not 12, it is 3, root 3. So 2 root 3, it will become root 3 upon 2. It will become root 3 upon 2. Cos C is root 3 upon 2. So cos C means this is cos 30. Cos 30, the value of cos 30 is root 3 upon 2. So C is 30. That is what we have to prove. The smallest angle is 30 degree. We have to prove the sides of a triangle are this. Prove the smallest angle is 30 degree. I told you that the smaller the side, the smaller is the angle opposite to it. Bigger the side, bigger is the angle opposite to it. So what we saw that we shows which is the smallest side in this triangle, and instead of calculating all the three angles, you just chose, you saw which is the smallest side. And I named them ABC. So I realized C is the smallest side. C is the smallest side. So angle opposite to C will be the smallest. And I calculated the cos of that. Once I calculated the cos C, I realized that C is coming out to be 30, which is what I had to prove. So smallest angle is 30 degrees. Now let's see the next question, that is fifth. Fifth question is, if A is 9, B is 8, C is 4, prove 6 cos C plus 4 plus 3 cos B. A is 9, B is 8, C is 4. All the three sides are given and cos C and cos B are given. So obviously you must apply the cos laws. Let us calculate cos C. Cos C will be B square plus A square minus C square upon 2AB. That will give me 64 plus 81 minus 16 upon 2 AB. A is 9 into 8. I get this value. How much will it be? 415, 8, 6, 14, 145 minus 16 upon 2 into 9 into 8. 129 upon, because 129 will cancel with 3 I think. 3 4s are 12, 3 3s are 9, 3 3s are 9. So 43 upon 48. It will be 4 plus 3, the value of cos B is 11 upon 24, 3 8s are 24, 8 4s are 32 plus 11 upon 8, that will be 43 upon 8. So left hand side is equal to right hand side, and finally it came out to be 43 upon 8, 43 upon 8. Now let us see question number 6. Sometime when you are substituting, you do make a mistake. Please be careful about that. When we are making it on the board, you definitely are liable to make it in your examination, and that will cost you the question like we did just now. Now let us see 6th question. The sines of angles are in the ratio 4:5:6. Prove cosines are in the ratio of this. Sines are in the ratio of this. The cosines will be in the ratio of this. We have to prove. We know sin A upon A is equal to sin B upon B is equal to sin C upon C is equal to K. Or we say sin A is equal to AK, sin B is equal to BK, and sin C is equal to CK. The ratio sin A is to sin B. He says sines are in the ratio of, it will be AK, BK, CK, and they are in the ratio of what? 4:5:6. 4:5:6. So they are in the ratio sin A, sin B, sin C are in the ratio of this. Now what we need to do is we need to calculate the cosines. We have to find out the ratio of cosines is 12:9:2. So let us find out cos A. Cos A will be B square plus C square minus A square upon 2BC. And now this will be A, this will be B, this will be C. This is A, this is B, this is C. So let us put their values. These are A, B and C, because AK, KK will cancel everywhere, ABC will come. So B square is 5 square 25 plus C square is 36 minus 16 upon 2BC, B into C, 5 into 6. 36 minus 16 is 20, 20 plus 25 is 45 upon 2 into 5 into 6, 5 9s are 45, 3 3s are 9, 3 2s are 6, so 3 upon 4. Cos A comes out to be 3 upon 4. Cos B will be A square plus C square minus B square upon 2AC. Now let us see what is A. A is 4 square 16, C square is 36 minus B square is 25 upon 2 into A, 4 into C, 6. It will be how much? 36 plus 6, 52 minus 25 upon 2 into 4 into 6. That will be 52 minus 25, 27 upon 2 into 4 into 6. 3 9s are 27, 3 2s are 6. 3 9s are 27, 3 2s are 6, so 9 upon 16. 9 upon 16. Now similarly, let us calculate cos C. Let us calculate the value of cos C, which will be A square plus B square minus C square upon 2AC, 2AB. 2AB. A is how much? 4 square is 16 plus 25 minus 36 upon 2 into 4 into 5. So 16 plus 25 will be 41 minus 36 41 minus 36 and 2 into 4 into 5, which will be 41 minus 36 will be 5 upon 2 into 4 into 5. 5 will cancel, 1 upon 8. So if you look at the ratio of cos A is to cos B is to cos C, let us look at the ratio of cos A is to cos B is to cos C. 3 upon 4 is 9 upon 16, 1 upon 8. What I will do is I'll multiply the complete, all the three ratios by 16. If I multiply it by 16, 4 4s are 16, 3 4s are 12. Then if I multiply it by 16, it will be 9. If I multiply it by 16, it will be 2. The ratio will be 12 is to 9 is to 2. Ratio is 12 is to 9 is to 2. The ratio is 12 is to 9 is to 2. So this is the sixth question. Okay, let's do question number 7 and 8. I have finished till 6. Let me pick up the question number 7. Sin A, we have to prove that sin A upon sin A plus B is equal to A upon C. Obviously sine is involved, sides involved, we should apply the law of sines. Left hand side, let's see the left hand side, sin A. I can convert this into sin C by writing 180 minus C. Sin A plus B, A plus B plus C is 180. So A plus B shall be equal to 180 minus C. So sin A plus B can be written as sin 180 minus C as well. So I have replaced sin A plus B with sin 180 minus C. And sin 180 minus theta is sin theta. So it will become sin C. Sin A is Ka, sin C is Kc. Kk will cancel, you will get A upon C, which you wanted to get. How did I get Ka? You know sin A upon A. Sin A upon A is equal to sin B upon B is equal to sin C upon C is equal to K. So sin A is AK, sin B is BK, and sin C is CK. It depends what you want. I could have reversed it. I could have written as A upon sin A, B upon sin B, C upon sin B is equal to K if I wanted to get the value of A. But here I want the value of sin A, so I substitute, put the sin A in the numerator. Sin A upon A is equal to sin B upon B is equal to sin C upon C is equal to K. So sin A is equal to AK, sin B is equal to BK, sin C is equal to CK. So sin A is replaced by KA, sin C is replaced by KC, KK will cancel, you get A upon C, which is I have to get on the right hand side. So I proved left hand side is equal to right hand side. Now let us see question number 8 in this. A minus B upon A plus B is equal to 10 half A minus B upon 10 half, this is capital A, this is capital B, A plus. The angles are always capital, these are sides which are written in this small letter. Now A minus B, A plus C, again I am going to convert them to the same form, like A will be K sin A minus K sin B upon K sin A plus K sin B. So it will become sin A minus sin B upon sin A plus sin B. We will use the formula sin C plus sin D, sin C minus sin D. Sin C minus sin D, if you remember, 2 cos a plus b upon 2 sine a minus b upon 2. Sine c minus sine d was 2 cos c plus d by 2 sine c minus d upon 2. In a sort of c and d I have a and b. So 2 sine here it is sine a plus sine b. Sine c plus sine d was 2 sine c plus d by 2 and cos c minus d by 2. So sine a plus b upon 2 and cos a minus b upon 2. 2 will cancel. We are supposed to get 10 a minus b upon 2. So sine a by 2, sine a minus b upon 2 divided by cos a minus b upon 2 will become 10 a minus b upon 2, and what will happen is sine a plus b by 2 upon cos a plus b by 2 will become 10 a plus b upon 2. That we get as the answer.